An octopus is basically an underwater ninja with 8 arms, perfect for multitasking or stealing your snacks. It is the only creature that can solve a puzzle and throw shade with its ink at the same time.
Octopuses are a new animal welfare frontier. What scientists know about consciousness in these unique creatures. We named him Squirt, not because he was the smallest of the 16 cuttlefish in the pool, but because anyone with the audacity to scoop him into a separate tank to study him was likely to get soaked. Squirt had notoriously accurate aim. As a comparative psychologist, I'm used to assaults from my experimental subjects. I've been stung by bees, pinched by crayfish, and battered by indignant pigeons. But somehow, with Squirt, it felt different. As he eyed us with his W-shaped pupils, he seemed clearly to be plotting against us. Of course, I'm being anthropomorphic. Science does not yet have the tools to confirm whether cuttlefish have emotional states, or whether they are capable of conscious experience, much less sinister plots. But there's undeniably something special about cephalopods, the class of ocean-dwelling invertebrates that includes cuttlefish, squid, and octopus. As researchers learn more about cephalopods' cognitive skills, there are calls to treat them in ways better aligned with their level of intelligence. California and Washington State both approved bans on octopus farming in 2024. Hawaii is considering similar action, and a ban on farming octopus or importing farmed octopus meat has been introduced in Congress. A planned octopus farm in Spain's Canary Islands is attracting opposition from scientists and animal welfare advocates. Critics offer many arguments against raising octopuses for food, including possible releases of waste, antibiotics, or pathogens from aquaculture facilities. But as a psychologist, I see intelligence as the most intriguing part of the equation. Just how smart are cephalopods really? After all, it's legal to farm chickens and cows. Is an octopus smarter than, say, a turkey? A big, diverse group, cephalopods are a broad class of mollusks that includes the coleoids, cuttlefish, octopus, and squid, as well as the chambered nautilus. Coleoids range in size from adult squid only a few millimeters long, Idiosepius, to the largest living invertebrates, the giant squid, Architeuthis, and colossal squid, Mesonychoteuthis, which can grow to more than 40 feet in length and weigh more than 1,000 pounds. Some of these species live alone in the nearly featureless darkness of the deep ocean. Others live socially on active, sunny coral reefs. Many are skilled hunters, but some feed passively on floating debris. Because of this enormous diversity, the size and complexity of cephalopod brains and behaviors also varies tremendously. Almost everything that's known about cephalopod cognition comes from intensive study of just a few species. When considering the welfare of a designated species of captive octopus, it's important to be careful about using data collected from a distant evolutionary relative.
Cuttlefish can form false memories, so when they tell you they didn't eat the last shrimp, they might actually believe it. They're basically underwater goldfish with a twist of drama.
Research reveals cuttlefish can form false memories too. During an event, details like what you saw, smelled, and felt aren't stored as a single memory. Rather, they are encoded and stored in your brain separately. To retrieve that memory, those pieces must get put back together. When that doesn't happen in the right way, or details are distorted, it can lead to the creation of false memories. Now researchers reporting in the journal iScience on July 17th have evidence that the common cuttlefish may create false memories too. Forming false memories is different from making memory errors, said Christelle José Alve of the University of Caen in Normandy, France. The results suggest that cuttlefish do not encode events as film strips, but rather mentally reconstruct the event by associating different features that were present during the original event, says Jose Alves. Cuttlefish have been recognized as the only invertebrates possessing episodic-like memory. In other words, they can remember and recall what happened to them in the past. But the underlying mechanisms involved in their ability to recall previous events weren't known. Does a cuttlefish's memory for past events depend on a reconstruction process? To find out, Jose Alves and colleagues decided to try and induce false memories in cuttlefish. If the animals rely on a reconstructive process for their episodic-like memories, they reasoned, then they should be susceptible to forming false memories. To encourage false memories, the researchers exposed cuttlefish to successive events, sharing many common features. They wanted to see if they could make cuttlefish remember seeing their favorite food, shrimp, in a particular tube, even when they hadn't. First, they showed cuttlefish different tubes, one with shrimp, one with a less preferred crab, and one empty. Each tube had a specific visual pattern. Next, they showed two of the three tubes previously encountered, the shrimp tube and the empty tube. But this time, the content of the tubes was not visible. They attempted to mislead the animals with the visual patterns and odors, creating overlapping features. The question was whether the cuttlefish would falsely remember there being shrimp in a tube that was in fact empty because they saw this tube a second time in the presence of the shrimp tube. To test it out, they let the cuttlefish choose between the empty tube and the crab tube with the contents not visible. And their choices suggested that the misleading information in those past events had altered their memories. Rather than choosing a tube containing their less preferred crab, the cuttlefish, more often than otherwise expected, sometimes chose an empty tube, suggesting they thought they remembered it contained shrimp. While more study is needed, the findings suggest that cuttlefish can form false memories for visual information but not for sense. The researchers suggest this memory strategy might reduce the cost of memory. If cuttlefish can store smaller building blocks of memories and then reconstruct them, it might optimize memory while allowing them to imagine different combinations of features in the future, the researchers suggest. However, they also noted an unexpected amount of variation among individuals. What was surprising was that the susceptibility to form false memories seems different between individuals, Jose Alves said. Some appeared unaffected when exposed to a misleading event, while others did form false memories. This phenomenon is commonly found in our own species, in which this susceptibility varies among individuals and within individuals. In future studies, they say it will be important to better understand why all individuals are not as sensitive to the formation of false memory and whether it could change within an individual depending on its age, its level of attention to the task, or even its emotional state.